Hello everyone. What I'd like to do in this video is, given a sketch of a piecewise function, let's try and find its formula. Go ahead and pause the video and give this a shot on your own before we do it together. Okay, let's do it. So let's notice with this piecewise function, let's notice that there are 4 different pieces that we need to record. Okay, so let's start with each of them. The first thing we're going to start with is, how about we work from the left and go to the right here. So the first thing we're going to try to do is let's try to figure out the equation of this line. Now the equation of any line, so I'm looking from, looks like from negative infinity up into negative 1. The equation of a line is y is equal to mx plus b. So I need to figure out what the slope of this line is, and I need to figure out what the y-intercept of this line is. So remember, to find the equation of any line, we really just need 2 points. So let's grab 2 points from this line. Okay, it looks like we have the point, looks like negative 3 and 5, negative 3 and 5, and we also have the point, looks like negative 1 and 1. So we want to find the equation of a line that contains these 2 points. So the first thing we'll do is we'll figure out the slope. So remember the slope, which is usually denoted with m. How about I write slope here? What slope is defined as rise over run. Or what it is a change. It's a vertical change. I want to know how much does my function change vertically when I move a certain unit horizontally. So if I think of it as like a staircase, if I were to move forward this much, and this would be my run, how much would I go down? In this case, I would have a negative slope. If I had a positive slope, how much would I be going up for every unit I move forward? That's what slope is. It's rise over a run. So it's a change in my y value, so that could be y2 minus y1 all over x2 minus x1. Now, it doesn't matter whether you call this your point 1 or this your point 2. Either one would work. How about we call this our point 1? So how about this is our x1 and our y1, and let's say this is our x2 and our y2. Okay, so our slope here, our y2 value is going to be 1. And we're going to be subtracting a 5, so y2 minus y1, all over x2, the negative 1 minus a negative 3. So I have a negative 1 minus my negative 3. So we're going to get out, looks like a negative 4, a negative 1 plus 3. So what do we get there? Negative 1 plus 3, that's going to be what, 2? So it looks like our slope here is negative 2. So let's see if that works. Well, notice if I were to go over 2 units from negative 3, over 2 units, that's what the 2 is. If I go over 2 units, I go down 4 units. 1, 2, 3, 4. So the slope is negative 2, 4. Or if I were to go over 1 unit, I'd be going down 2 units. So over 1 unit, down 2 units, over 1 unit, down 2 units. So the slope here is negative 2. Okay, so what we have so far is we have that, let's erase a little bit of this here. We're almost finished. So what we know so far is that y is equal to negative 2x plus b. Now, our job here is to figure out what this b will be, which will be our x-intercept. What will be our y-intercept. Notice if I plug in 0, for x, plus b, our y would just be equal to b. So this b does represent the y-coordinate of the y-intercept. Okay, how am I going to figure that out? Well, to figure out what b it needs to be, I need to recognize that this is just a line of slope negative 2. There are an infinite number of lines that have a slope of negative 2. I need to make sure it's the line that contains one of these 2 points. So it's not enough for me just to tell you the slope of a line. I need a point to lock that line in place. So you could either use this point or this point. Either would work. Let's use this point. So what we're going to do is we're going to plug in x. For x, we're going to plug in negative 1. For y, we'll plug in 1. We'll solve for b to figure out what b needs to be to make sure that this point is on this line. So plugging in 1 for y and negative 1 for x, I'm going to get that 1 is equal to what? 2. Plus b. If I subtract 2 from both sides, I'm going to get that b is going to be equal to, looks like, negative 1. Okay, so we have the equation of our line. We have that, let me erase a little bit of this here. Let me go write it up here. We have that y is going to be equal to negative 2x minus 1. So we can verify that this point is on the line. For instance, if we plug in -1, we're going to get -2 times -1 minus 1. What do we get? 2 minus 1. We get an output of 1. Sweet. Now you could use either of these points. This point should also be on this line. We got this point from the slope. You could verify this. If I were to plug in -3, I better get an output of 5. So -2 times -3 minus 1, plugging that in here. What am I going to get? I'm going to get a 6 minus 1. I get out of 5. So both of these points are on this line. Okay, so that's how we find the equation of a line. So what we have here, this function, let's call it f of x. What we have here is that f of x is going to be equal to, looks like we're going to get a -2x minus 1, but for where? Looks like it's this line when I'm less than -1. So when x is less than, since there's a closed dot here, less than or equal to -1. Okay, let's move on to the next piece. So I have this piece of the function between -1 and 1. So maybe I'll go ahead and record that right off the bat. Now I'm thinking about values between -1 and 1. I'm not including -1, but I am including 1. And notice that anywhere between -1 and 1, if I plug in any value, the output will always be 3. So if you plug in any number between -1 and 1, the output will always be 3. Okay, let's look at, what do we have to look between? We have to look now between, looks like 1 and 4. So it looks like I'm including 4 and I'm not including 1. Okay, now let's think about what this function is. This looks like a lot like a parabola. And it looks like its vertex has been shifted to the right 2 units. So thinking about our transformations, or thinking about our toolkit functions being transformed, this looks a lot like x. I'm shifting to the right 2 units, so x minus 2 quantity squared. Now it could be a vertically stretched version. Now we could check this. So if I plug in, let's say if I plug in 4, for example, if I plug in 4 just to check, 4 minus 2 squared, I better get an output of 4. 4 minus 2 is 2, 2 squared, we get out 4. So I would agree that the shape of this graph here is x minus 2 quantity squared. So we'll have a x minus 2 quantity squared if x is between 1 and 4, not including 1 and including 4. Okay, for the last one, we just need to talk about when x looks like is strictly bigger than 4. When x is strictly bigger than 4, my outputs are always 1. So we'll put a 1 here. And here is a formula for the graph of this piecewise function. I hope you found this helpful. We'll see you in the next video. Take care.